In this video, we're going to convert binary numbers to decimal numbers. Before we start converting, I want to examine a regular decimal number. I'm going to take 235 and write it in this format. 100 times 2 plus 10 times 3 plus 1 times 5. This is the 100's place, so I'm going to put a 100 there. This is the tens place, so I'm going to put a 10 there. This is the ones place, so I'm going to put a 1 there. I'm taking the 2 and moving it down here. The 3, moving it down here. The 5, moving it down here. I could also write the number in exponent format. 10 to the 2 times 2. 10 to the 2 equals 100, plus 10 to the 1 times 3. 10 to the 1 equals 10, plus 10 to the 0 times 5. Anything to the 0 is 1. I want to examine this number here. 100 equals 10 to the 2. 2 represents the position, and 10 represents the base. This will help us out later when we're trying to convert binary numbers to decimal numbers. So 10 to the 2 times 2 is 200, plus 10 to the 1 times 3 is 30, plus 10 to the 0 times 5 is 5. So we end up with 235. I'm going to do the same thing with a binary number. There's 8 positions here. 0, 1, 2, 3, 4, 5, 6, 7. 0 through 7, 8 positions. So the same thing that we did with the previous number, I'm going to do with this number. The base is 2. It's a binary number. And this is position 7. 2 to the 7 times 1, plus 2 to the 6 times 0, plus 2 to the 5 times 1, plus 2 to the 4 times 0, plus 2 to the 3 times 1, plus 2 to the 2 times 0, plus 2 to the 1 times 0, plus 2 to the 0 times 0. This is the base, it's a binary number, and this is the position. Base, position, base, position, base, position. And this is my binary number. I just copied it down. 101010000. 2 to the 7 equals 128. 2 to the 6 is 64. 2 to the 5 is 32. 2 to the 4 is 16. 2 to the 3 is 8. 2 to the 2 is 4. 2 to the 1 is 2. 2 to the 0 is 1. 128 times 1 plus 64 times 0 plus 32 times 1 plus 16 times 0 plus 8 times 1 plus 4 times 0 plus 2 times 0 plus 1 times 0. And I would end up with 128 plus 0 plus 32 plus 0 plus 8 plus 0 plus 0 plus 0. This comes out to 128. This comes out to 0. This comes out to 32. This comes out to 0. This comes out to 8. This comes out to 0. This comes out to 0. This comes out to 0. So if I remove the zeros, 128 plus 32 plus 8 equals 168. So the binary number 10101000 is equal to the decimal number 168. So we've just done our first conversion. This is a little tedious to do every single time. So what we can do is use these values and create a chart. If you notice, every time there's a 0 in the binary number, it would be 0 here. So the only ones we really need to be concerned with is the values where the binary number is a 1. This position has a value of 128. This position has a value of 64. This position has a value of 32. This position has a value of 16. This position has a value of 8. This position has a value of 4. This position has a value of 2. And this position has a value of 1. and we only add that value when the binary number is 1. So in this case, I would add 128, 32, and 8. So we're going to put this in a chart format. So here's our chart. We have 2 to the 7, 2 to the 6, 2 to the 5, 2 to the 4, 2 to the 3, 2 to the 2, 2 to the 1, 2 to the 0. 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2 to the 4 is 16, 2 to the 5 is 32, 2 to the 6 is 64, 2 to the 7 is 128. So I'm just going to place my binary number right in this chart, and we'll figure it out. Here's our first binary number, 11000011. So all I need to do is add the values where that bit is turned on. 128 is turned on, so I add it. 64 is turned on, so I add it. 2 is turned on, so I add it. 1 is turned on, so I add it. If I total that number up, it equals 195. So 11000011 equals 195. Here's another binary number, 101000101. So what I need to do is add 128 plus 32 plus 4 plus 1. That equals 165. Here's our next binary number, 111000010. What we need to do is add 128 plus 64 plus 32 plus 2, and that will equal 226. Now this is a little trick I'm going to show you. This binary number is 0001111. If I add all these values up, they're 1 less than 32. So if I add 16 plus 8 plus 4 plus 2 plus 1, it equals 31. If all these bits were turned on and these two were off, that would be a value of 63. If only these three were turned on and all these were off, it would be a value of 7. So that's a good trick, especially when we do subnetting later. As networkers, we really deal with only 8 bits. The minimum value you can get in 8 bits is 0. That's with all the bits turned off. If all the bits were turned on, the maximum value we can get is 255. So the range of values can be anywhere from 0 to 255, using only 8 bits. To practice what we've just learned, start plugging in ones and zeros into the chart and figure out the answer. Then you can use the Windows calculator to double check your work. Open up the calculator, click on View, then click on Programmer's View. Once you're here, click on the binary radio button. Type in the binary number. When your binary number is typed in, click on decimal. That will convert it to a decimal number. Then you can check your answer. Okay, that's it for this video. Thank you.